Okay, in this video we're going to look at the three forms of parabolas. Previously we learned about the vertex form, which is a times x minus h squared plus k, where h and k were my vertex. We then did the math and used order of operations to take that to standard form, which is a x squared plus bx plus c. And today we're going to talk about factored form, which is also known as intercept form. Okay? Which is x minus a times x minus b. In your packet, we talked about Optima and her quilt business, and before they were building quilts all in the shapes of squares. Well, now they've decided to expand their business and form them into rectangles. So the first one was they were given the traditional quilt is x by x, but they decided to extend one side by 5 and extend the other side by 2. So that's why we have x plus 5 times x plus 2. And they'd like us to illustrate this so that we can find out the area. So we're going to do that as one form, and then I will show you another way. So we have x by x, and then we're going to add 5 pieces. 2, 3, 4, 5. And really the pieces should have ended there. I kind of extended them a little bit more. And that's my plus 5. And then we have 2 pieces on the other side. So 1 and 2. Okay? So when I look at these, each one of these is 1x. So I have 1x, 2x, 3x, 4x, 5x, 6x, 7x. And this was x squared. So I have x squared plus 7x for each of these skinny rectangular pieces. And then if I extended my rectangular pieces to fill in this area right here, which is going to be 2 by 5, which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gives me 10 little individual squares. So plus 10. So that's how to do it using algebra tiles. Let's look at another way. The other way is known as FOIL or double distribution, and we learned the distributive property earlier in the year. So think of it as this. Pretend this is the papers I'm passing out, and these are the students. Okay, the first thing I passed out today was the warm-up. I'm going to call that X. I gave X to student X, and I gave X to student 2. I gave it to each person. So X times X gives me the X squared. Let me erase so you can see. Let me go ahead and put this over here. This picture was X squared plus 7X plus 10. Okay, so when I did X times X, that gave me the X squared. And then I'm going to do X times 2 to share it with student 2, and that gives me 2X. Then I'm going to come back. I've shared that. I gave you a packet today, so I'm going to call that 5. And I shared 5 with student X, which makes 5X. And then I shared 5 with 2. And 5 times 2 is 10. Now, these are both x's, so I can combine them so that my final answer is the x squared. 2 plus 5 is 7, 7x, and then bring down the 10. Notice both of these answers match. Now, some of you were using the shortcut, which works because this is only a 1x and this is only 1x, which is the middle term you get by adding and the final term you get by multiplying. Okay? But you'll see later that that's not going to be the case because our x is going to start changing. Okay, so once again, the original quilt was x by x. So they got an order where they want to take the original and they want to extend one side by 3 and they want to extend the other side by 4. Now at this time, you can pause the video. You can either draw this out and solve it that way, or you can use the double distribution FOIL. Okay, I'm going to go ahead and use double distribution. So x times x is x squared. X times 4 is 4x. Now, a lot of times students want to say 2x. Remember, this is x times x. So when we did 3 times 3, that was 3 squared. I know that 3 times 3 is also 9, but when I don't know the value of x, I can only show it this way, that there are 2 x's involved, because I don't know the value of x. So x times x is x squared. Just something to think about. Now I'm going to come back, and I'm going to share 3. Also, if you have trouble, you can take an index card and you can cover up each of the pieces as you distribute them, so you don't lose track. 3 times x is 3x. 3 times 4 is 12. Combining like terms, I get x squared plus 4 plus 3 is 7x plus 12. Okay, let's move on to the next problem in the packet. The original square was extended 4 inches. So original extended 4. And then they left the other side alone. So the other side is x. The original was x. Okay? Going ahead, and I'm going to distribute. The x times x is x squared. There's nobody else over here to share with, so I'm done with this one. I'm going to come back and share 4. And 4 times x is plus 4x. So my answer is x squared plus 4x. Just a reminder, at any time after I read the problem, you can pause it before I start to show the work if you want to do the work and check yourself. Okay. In the next scenario, the original was extended by 5 inches on each side. Each side. So side 1 gets extended by 5. Side 2 gets extended by 5. My length increased by 5. My width increased by 5. Okay? So if you remember, this is also the same as saying x plus 5 squared. And if you remember the shortcut, you can use the shortcut. I'm just going to go ahead and double distribute. So we have x squared plus 5x plus another 5x plus 25, which gives me x squared plus 10x plus 25. Again, 5 plus 5 is 10. 5 times 5 is 25. All right, next one. The original square was extended by 2 on one side and extended by 6 on the other. X times x, x squared. X times 6 is 6x. 2 times x is 2x. 2 times 6 is 12. Combining like terms, we get x squared plus 8x plus 12. Going a little bit faster here now. Okay, moving on. The original square was extended by 2 and decreased by 2. All right, so we have x times x is x squared. Be careful, x times a negative 2 is negative 2x. 2 times x is 2x. 2 times a negative 2 is negative 4. Now, I have a negative 2 and a positive 2, so they cancel, and I'm left with x squared minus 4. Now, if you wrote x squared plus 0x minus 4, that's okay, but it's not the simplest form. Whenever there's a 0 with the variable, remember 0 times anything is 0, so it's not necessary to write. All right, the original, both sides were decreased by 3, both sides. So you can write it like this or like this. All right, I'm not going to show the double distribute. I'm going to do my shortcut. So I have x squared minus 2 times 3 is 6. So 6x. 3 times 3 is 9. So x squared minus 6x plus 9. Okay, the real lesson here is taking the words and being able to write it in factored form, because you guys are really good at switching to standard form. So I'm doing that a little bit quicker. All right, number 11, one of the last problems. I skipped a problem. I'm sorry. So I'm going to go out of order. I'm going to go ahead. This is actually number 9 in your packet. And I will come back and, oh, sorry. I hit the arrow too fast. Okay, so this is really number 8 in your packet. The original square was extended by 5, so our original extended by 5 and doubled on the other. So some people had trouble with this. They did x plus 10 because they thought double this. But double the original. The original is x, so when I double it, it is 2x. It is not doubling the extension, it's doubling the side. So if the side was x, double that is 2x. Share x with 2x, that is 1 times 2 is 2. X times x is x squared because there's 2 x's involved. Now 5 times 2x, 5 times 2 is 10, and the x is there to tag along. Okay, last one, a little tricky. Here we go. Each side of originals was tripled. Now remember the original was x, so when I triple that, that means 3 times, and then decrease by 1. And it's to each side, so you can either write a squared here, or you can just write it out. I'm going to write it out so we can do the double distributive property. Okay, 3 times 3 is 9. The x times the x is the x squared. 3 times negative 1 is negative 3x. Then I come back and we're going to do, this time I'm going to share negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. Remember, when adding or subtracting, if the signs match, you're going to add. So I get 6. Keep the sign as negative. So 9x squared minus 6x plus 1. Okay, just a reminder, you had one homework problem, and it was x plus 7 times x plus 5. I'm not going to go over the answer here. Just a reminder what your homework was. Good luck.